Okay, this video is the continuation of section 9.1, and that's dealing with the basics of probability. So we're gonna pick up with that particular section. So here we're gonna start this video with complementary event. Okay, we're gonna find out what that means. All right, if we know the probability of E, then we can use the following complement rule to find the probability that E does not occur. So here's the complement rule here in this orange box. We're going to let S represent the sample space of an experiment and E be any event. The complement of E, which is going to be denoted by a squiggly mark in front of the letter E, that's going to consist of all outcomes in the sample space S that do not belong to E. Okay? So, that notation is going to be the probability that E does not occur. And also, this is going to be very important. The probability that E does not occur is always going to be equal to 1 minus the probability of event E occurring. So, to find the complement, we do 1 minus the probability of event E. Or the probability of the complement of E, as I should say. Okay, take a look at this example here. In part A on a test, 85% of students gave the correct answer to a particular problem. What is the likelihood that a randomly selected student did not give the correct answer? Okay, so let me go to this next slide and show you the answer there. Well, that's just simple. We just do 1 minus 0.85, which will be 0.15. That's going to mean that there is a 15% chance that a randomly selected student did not give the correct answer. Okay. And in part B, an experiment consists of randomly drawing a card from a standard deck of cards. What is the probability that the card is not a 7? So here's the answer to part B. The probability of drawing a 7 is going to be 4 over 52. There are only 4 sevens in a deck of 52 playing cards. So 4 out of 52 is that probability. So the probability of not drawing a 7 will be 1 minus 4 over 52, which will end up being 48 over 52. So if you know that 52 cards in a deck and there are only 4 sevens, the rest will have to be 48. So it'll be 48 over 52, or 92%. So the probability that a card is not a 7 is about 92%. Alright, so in problem number 35 on page 506, what is the probability that a randomly chosen number from 1 to 100 is not a multiple of 6? Okay, is not a multiple of 6. Now this is where we're going to need to list the multiples of 6, if we can. And that's how I did this problem. So here, we start with 6 and then 12, 24, 36, 30, then 36. Now 42, 48, 54, and then 60, 66, 72, 78, 84, 90, 96. Those are the multiples of 6 between 1 and 100. So if you count the multiples of 6, here we got 2, 4, 6, 8, 10, 12. Am I missing something here? I know, 18. 6 and then, yeah. That's a multiple of 6, so I'm missing 18, so it'll be 2, 4, 6, 8, 10, 12, 14, 16. So the probability of selecting, randomly choosing a number that is a multiple of 6 between 1 and 100 would be 16 out of 100. Now, if we want the complement of that, because it asks for the probability that a randomly chosen number from 1 to 100 is not a multiple of 6. So, not a multiple of 6 would be 1 minus the probability of getting a multiple of 6. So, it would be 1 minus 16 out of 100, which will be 1 whole in hundreds will be 100 over 100. And we'll end up with 84 over 100. And of course, it's already with a denominator of 100, so it'll be 84%. If you were to write that as a percent. Okay. All right, now here's another example that deals with the complement. An experiment has exactly 3 outcomes, A, B, and C. Suppose the probability of event A is 0.20 and the probability of event B is 0.35. Find the probability that in part A, C occurs, and part B, C does not occur. Well, I know this. We'll start with part A. The probability of event A, the probability of B occurring, and the probability of C occurring. That does equal to 1. So, the probability of event A will be 0.20. Plus the probability of B occurring will be 0.35. And the probability of C is what we're trying to find. That should equal to 1. Now add 0.20 and 0.35 together, you're going to get 0.55. Plus the probability of C occurring will be equal to 1. Now this is like solving an equation, so to find out what the probability of event C is occurring, if I move the 0.55 over to where the 1 is, it's going to be a minus 0.55. So the probability of event C occurring will be 0.45, 1 minus 0.55. And then the probability that C does not occur. I'm going to use its notation, not C. That would be 1 minus the probability that event C occurs. So in this case here, 1 minus 0.45, which will be 0.55. That's similar to the sum of the probability of event A and B occurring. Or just say A or B occurring. Okay. So that's how we deal with the complement of events. Now, we'll talk about comparing probabilities. I believe that's going to be the last thing in this video that I'll talk about, comparing probabilities. It is common to compare probabilities using phrases such as 25% more likely, or 30% less likely, or 4 times as likely. These are multiplicative and not additive comparisons because they involve multiplication, percent, or both. We have seen these types of comparisons before, but now we're applying them to probability situations. So here the phrase, A is 60% more likely than B means this, that the probability of event A will be equal to the probability of event B plus 60% times the probability of event B. Okay. And the phrase A is 15% less likely than B means this. The probability of event A is equal to the probability of event B minus 15% times the probability of event B. And finally, the phrase A is 3 times as likely to occur as B would mean this. The probability of event A would be equal to, and of course the word is means the equal to, 3 times as likely to occur as B, 3 times the probability of event B. The media and researchers often report probability comparisons using the casual phrases times more likely and times less likely, rather than the phrase times as many. Okay. So, in this case here, times more likely is that students who participate in the arts are 4 times more likely to earn recognition for academic achievement. The phrase A is 4 times more likely to occur than B means this. The probability of event A is equal to 4 times the probability of B. Thus, 4 times more likely really means 4 times as likely. And times less likely, in this situation, a study shows patients with surgeries scheduled at about 9 a.m. were 4 times less likely to request pain medication than patients with surgery scheduled at about 4 o'clock p.m., according to the journal Quality and Safety in Healthcare. Now this continues on the next slide. If I can pull this up. The phrase B is 4 times less likely to occur than A means the probability of event B is 1/4 times the probability of event A. Thus, 4 times less likely really means 1/4 times as likely. Now, you'll have to look this in your book, and I can also post this on Blackboard if you would like, but this is the concept map that illustrates probability comparisons using words, equations, and diagrams. Okay? But let's look at example 15 here. An experiment consists of randomly drawing a marble from a jar containing green, blue, yellow, and white marbles. The probability of getting a green is 5 out of 20. The probability of getting a blue is 4 out of 20. And the probability of getting a yellow is 3 out of 20. And the probability of white is 8 out of 20. Verify each statement. So in part A, a green marble is 1.25 times as likely to be drawn as a blue marble. Okay, so let me go to this right here. Here I need to verify the equation that the probability of getting a green is equal to 1.25 times the probability of getting a blue. Because it says here 1.25 times as likely to be drawn. Likely to be drawn as a blue marble. Okay, so here, that's our equation. Now the probability of getting a green is 5 out of 20, and then that should be equal to 1.25 times the probability of getting a blue, 4 out of 20. If you multiply 1.25 times 4 out of 20, you're going to get 0.25. And 5 over 20 would also be 0.25. So we verified that a green marble is 1.25 times as likely to be drawn as a blue marble. Okay. In part B, a green marble is 1.6 times as likely to be drawn than a white marble. So let me move this up to part B. Here's the solution. And it says 1.6 times less likely. So we're looking at 1.6 times the probability of getting a green marble than a white marble. So the probability of getting a white marble will be 1.6 times the probability of getting a green marble. So here the probability of a white marble is 8/20ths, and then that should equal to 1.6 times the probability of getting a green marble, 5 out of 20. Well, 8/20ths as a decimal will be 0.40, and the 5/20ths will be 0.25. So 1.6 times 0.25 will give you a 0.40 as well. So we verified that the green marble is 1.6 times less likely to be drawn than a white marble. Okay, and part C is this. A yellow marble is 25% less likely to be drawn than a blue marble. So here's how they work that out. The probability of getting a yellow marble, that's probability of yellow, is going to be equal to the probability of getting a blue minus 25% times the probability of getting a blue marble. The probability of a yellow marble will be 3 out of 20. That should be equal to the probability of a blue marble, that's 4 out of 20, minus 0.25 from 25% as a decimal times 4/20ths, the probability of a blue marble. Multiply this, you'll get 0.05. 4/20ths will be 0.02. 0.2 minus 0.05 will be 0.15. Do 3 divided by 20, you'll get 0.15 as well. So this verifies that a yellow marble is 25% less likely to be drawn than a blue marble. So that's how we compare probabilities here. Now let's look at this, problem number 61 on page 507. Suppose the probability of event A is 0.38 and the probability of event B is 0.48. So here we're going to be verifying each of these probabilities, starting with part A. I want to verify that A is about 21% less likely than B. So here I'm going to have to write this out on separate paper here. So to interpret that, I want the probability of event A to be equal to this. The probability of event B, less likely I need to subtract 21% of that. Well, 21% would be 0.21 times the probability of event B. So that probability minus 21% of the probability of event B has to be equal to the probability of event A. Well, the probability of event A was 0.38. That should equal to, and I'm going to put a question mark above that, the probability of event B was 0.48 minus 0.21 times the probability of event B, 0.48. So this is going to be 0.38. Now, all of that you can type in the calculator if you like. So in this case, let me clear this out. If I do 0.48 minus 0.21 for the 21% times 0.48, which is the probability of event B, let's round this off to 2 decimal places. It's going to be about 0.38. So you can see here the left side and the right side are the same, or about the same. So I verified that A is about 21% less likely than B. Now part B. B is about 26% more likely than A. So let's interpret that. Well, B is, that's the probability of event B, and is the equal sign. And I'm dealing with the probability of event A, so I have to write this as the probability of event A itself minus 26%, not minus, plus, because it says more likely. More likely. So I have to say plus 26% or 0.26 times the probability of event A. Now the probability of event B was 0.48. That should equal to the probability of event A was 0.38 plus 0.26 times the probability of event A. that was 0.38. So the left side I have 0.48. I'm going to say approximately equal to here. If I do 0.38 plus 0.26 times 0.38, I should get about 0.48. I'll go ahead and show that to you on the calculator. 0.38 plus 0.26 times 0.38. It says 0.4788. Round that up to 2 decimal places, you'll get about 0.48. So I verified that B is about 26% more likely than A. And finally, B is about 1.6 times as likely as A. So this is written a little bit different. So here, B will be the probability of event B. The is the equal sign. 1.26 as likely would be times the probability of event A. And your probability of event B was 0.48. That's equal to 1.26 times the probability of event A was 0.38. I want to note that left side equals the right side. So if I do 1.26 times 0.38, I got 0.4788, round that up, it'll be 0.48. So here I verified that B is about 1.26 times as likely as A. Okay. Okay, so that's how we compare probabilities here in this section. Okay, so this will conclude section 9.1 dealing with the basics of probability. So the homework should be available to you on WebAssign to complete, so make sure you have that done. And always you can email me if you have any questions about the problems in that particular section.